the farthest far-off fake article in the universe. NASA's Explorer 1 test is purportedly radiating valuable information back to Earth. We can quantify the universe regardless of whether we have no idea what it is. The popular NASA shuttle Explorer 1, which was launched quite a while ago, has now returned a signal that has stunned the scientific community. Explorer 1 has found something so critical that it has changed the course of its central mission and is now heading back towards Earth after traveling more than 14 billion miles away. Come on this cosmic journey with us. Explorer 1 made a stunning discovery just 7 minutes ago as it made a beeline for Earth. But what exactly could this discovery be? Could it be a cosmic deviation, evidence of alien life, or something even more fantastic? We will uncover these surprising revelations in this compelling analysis, as Explorer 1 has just made a staggering discovery that caused it to suddenly turn back toward Earth. Let's dive into the historical background of the Explorer twin probes. These two astonishing spacecraft might never have left Earth if certain cosmic events hadn't aligned. The 4 largest planets in our solar system were fated to align in perfect order. During this rare event, these planets slowly aligned nearly 50 years ago, a phenomenon last observed in the early 19th century during the administration of Thomas Jefferson. Initially, this extraordinary planetary alignment was largely overlooked. However, in 1965, Gary Flandreau, a PhD student in aerospace engineering at the California Institute of Technology, was the first to realize its significance at NASA's Jet Propulsion Laboratory in Pasadena, California. During the early years of space exploration, Flandreau worked part-time and was tasked with determining the most efficient way to launch a spacecraft to Jupiter, or even farther to Saturn, Uranus, or Neptune. He carefully mapped the orbital paths of these massive planets with a simple pencil and discovered something astonishing. All 4 giant planets would align perfectly for a single mission in the late 1970s and early 1980s. Because of this alignment, a spacecraft could use the gravitational slingshot effect to propel itself from one planet to the next, significantly reducing travel time. According to Flandreau's calculations, this alignment would cut the journey from Earth to Neptune from 30 years down to just 12. However, there was a catch. This particular planetary alignment only occurs once every 175 years. To take advantage of this extraordinary opportunity, a spacecraft would have to be launched by the mid-1970s. NASA designed 2 spacecraft to complete this mission, seizing this once-in-a-lifetime chance. Explorer 1 and Explorer 2 were launched on an incredible mission to investigate the outer planets of our solar system. The launch of the Explorer twin probes on September 5, 1977, was remarkable due to the planetary alignment and Gary Flandreau's groundbreaking calculations. Explorer 1 was launched into space from Cape Canaveral, Florida, aboard a powerful Titan IIE Centaur rocket on August 20, 1977. Just 15 days later, Explorer 2 was launched. Explorer 1 joined this cosmic journey by following a shorter trajectory as it embarked on its mission into the vast universe. Their primary objective was to study the solar system's massive gas giants, such as Jupiter and Saturn, along with their moons. However, these daring space explorers exceeded all expectations. They traveled farther and longer than any other spacecraft in history, pushing the boundaries of exploration. Throughout their incredible journey, they set numerous records, venturing into regions of our galaxy that were previously unknown, interstellar space. Explorer 1 and Explorer 2, these pioneering spacecraft, are now more than 12 billion miles from Earth. The astonishing discoveries they continue to make still amaze scientists. Decades ago, at the beginning of their incredible journey, the Explorer spacecraft stunned scientists by providing the first-ever close-up views of Jupiter and Saturn's moons. These moons, once thought to be as barren and cratered as our own, turned out to be dynamic worlds. In 1986, Explorer 2 made history by becoming the first of the twin probes to fly past Uranus. 3 years later, it accomplished a feat no previous spacecraft had achieved. It sped past Neptune. NASA employed innovative strategies to ensure the spacecraft remained operational during their extended journey. To conserve energy, non-essential components, such as heaters and extra instruments, were turned off. The goal was to maintain the spacecraft in working condition for as long as possible, at least until 2013. For the dedicated scientists and engineers who have been part of this extraordinary mission since its inception, it has been a journey of mixed emotions. Their perseverance has paid off, as just when they thought the Explorer missions were coming to an end, an astonishing discovery was made in deep space. Over 40 years ago, at the start of their incredible mission, the Explorer spacecraft shocked scientists with their first close-up images of Jupiter and Saturn's moons. These moons turned out to be colorful, vibrant worlds, contrary to the initial belief that they were dull, heavily cratered bodies like our own moon. Just 546 days after launch, in March 1979, Explorer 1 arrived at Jupiter. That same year, in July, Explorer 2, following a slightly different trajectory, also reached the planet. The onboard cameras of both spacecraft used special filters to capture full-color images. Interestingly, despite traveling through space at speeds more than 10,000 times slower than a clock's hour hand, the probes were designed to be extremely stable. This stability ensured that the images they captured were sharp and clear. The explorers took more than 33,000 pictures of Jupiter and its moons during their mission, each revealing fascinating new information. One of Jupiter's 53 known moons, Europa for example, was found to have an estimated 60 miles or more of cracks in its icy surface. As they left the Jupiter system, a gravitational slingshot effect provided the spacecraft with a final acceleration, propelling them to speeds of 35,700 miles per hour. Moved by the drive that empowered them to reach interstellar space, the explorers headed out in different directions as they arrived at Saturn. In the wake of flying by Titan, a moon covered in an orange fog, and passing through Saturn's glorious rings, encountering effects from infinitesimal dust particles, Explorer 1 left the planet's plane and traveled north in 1986. Explorer 2 completed its own journey and arrived at Neptune and Uranus. Its mission to Uranus led to the discovery of 10 new moons, elevating Uranus to the status of a planetary system world with rings. However, misfortune overshadowed the achievements of Explorer 2 when the Space Shuttle Challenger tragically exploded shortly after takeoff, killing all 7 crew members, including New Hampshire secondary teacher Krista McAuliffe, who was set to become the first civilian space traveler. Only 4 days after its closest approach to Uranus, where winds reached speeds of 1,000 miles per hour, Explorer 2 encountered the fastest winds ever recorded on any planet in our solar system. It soared nearly 2,800 miles above Neptune's stunning blue methane sky. Neptune's largest moon, Triton, one of the coldest places in our cosmic neighborhood, with surface temperatures as low as -235 degrees Celsius, revealed another astonishing discovery. Frozen volcanoes that erupted nitrogen gas and tiny particles up to 5 miles into the atmosphere. Following the captivating visuals of Neptune and its moons captured by Explorer 2, both spacecraft were scheduled to turn off their cameras, marking the official conclusion of their missions. However, the imaging team, led by astronomer Carl Sagan, intervened. NASA had extended the project in hopes that the explorers would venture beyond interstellar space. Although the Grand Tour was officially over, the spacecraft were renamed the Voyager Interstellar Mission and scheduled to continue their journey into space. In 1990, Sagan convinced NASA to allow Voyager 1 to capture a final set of images on Valentine's Day. After reorienting its cameras toward the inner solar system, the spacecraft took 60 final images. One of these images, famously dubbed the pale blue dot by Sagan, showed Earth from a staggering distance of 3.8 billion miles. The image depicted Earth as a tiny speck, barely visible against the vast darkness of space, illuminated only by a faint sunbeam reflecting off the camera's optics. Voyager's journey beyond the heliosphere. In August 2012, Voyager 1 officially crossed the heliosphere, an enormous bubble of charged particles emitted by the Sun, marking an extraordinary milestone. The following year, scientists confirmed this groundbreaking discovery in the journal Science. Between April 9 and May 22, 2013, Voyager 1's plasma wave instrument detected a significant solar eruption. This event caused nearby electrons to vibrate, indicating that the spacecraft had entered a region with a higher particle density than within the heliosphere. Initially, this seemed counterintuitive, as electron density near the heliosphere's boundary is significantly lower than on Earth's surface. However, after extensive data analysis, scientists determined that August 25, 2012, was the official date of Voyager 1's entry into interstellar space. This conclusion was supported not only by electron oscillations but also by observations of charged solar particles recorded by the spacecraft. The Voyager team was elated by this discovery. Project manager Suzanne Dodd expressed their excitement. "We are thrilled to have been able to continue operating Voyager and witness its achievement of reaching interstellar space. This milestone provided new insights into how our solar system interacts with the rest of the galaxy." Ed Stone, a key figure in the Voyager mission since its inception, remarked, "Voyager has led us to new discoveries by giving us the first-ever view of this unexplored region. By expanding our scientific understanding of energy and radiation in space, researchers are gaining valuable data on how our solar system communicates with the galaxy." Notably, in November 2018, Voyager 2 also entered interstellar space, exploring uncharted regions beyond the Sun's protective bubble that shields us from cosmic radiation. The mysterious discovery of Voyager 1. Despite its primary mission ending long ago, Voyager 1 continues to send valuable data back to Earth, an astonishing feat after 46 years and a record-breaking journey of 14.7 billion miles. However, recent transmissions have baffled scientists. During Voyager 1's deep space journey, something unexpected occurred. The spacecraft began relaying data about an anomaly in both its trajectory and the information it was receiving. The transmissions hinted at the presence of an enormous, yet unseen, object exerting a powerful gravitational pull, altering Voyager 1's course. This revelation stunned the scientific community. Speculation quickly arose. Could it be a rogue planet, black hole, or something entirely unknown? The implications were staggering. If confirmed, this newly discovered object could challenge fundamental assumptions about the universe. In response, NASA assembled an emergency scientific team to investigate. Utilizing every available resource, they aim to analyze Voyager 1's data and may even attempt to maneuver the spacecraft closer to the anomaly to gather additional information. Voyager 1's journey has taken an unexpected turn, serving as a reminder of the vast cosmic mysteries that lie beyond Earth and the unyielding spirit of exploration that drives humanity to seek answers in the deepest reaches of space. The longevity of Voyager's mission. Originally designed to last between 4 and 12 years, Voyager 1 has exceeded all expectations, continuing its mission for an incredible 45 years. Powered by 3 radioisotope thermoelectric generators, which convert heat from the radioactive decay of plutonium-238 into electricity, the spacecraft has endured long beyond its anticipated lifespan. NASA predicts that by 2025, Voyager's power supply may decline to the point where it can no longer operate its instruments or send data back to Earth. However, something extraordinary recently occurred. While communicating with Voyager 1 using NASA's Deep Space Network antennas, engineers noticed a sudden and dramatic shift. For over 40 years, the spacecraft had transmitted data continuously, until, without warning, it came to an abrupt halt and executed a complete 180-degree turn. Scientists and engineers were shocked and deeply concerned by this unprecedented behavior. At first, Voyager 1 was unresponsive to NASA's commands. But soon after, it resumed transmitting data that has both astonished and alarmed researchers. According to the latest information, Voyager 1's trajectory has been disrupted by an enormous, previously unknown object exerting an immense gravitational force. Now, the race is on to identify the nature of this object and determine how it fits into our understanding of the universe.